Hello everybody, we're going to take a look at Unit 5.2J of area, volume, and temperature, and this is composition of solids. So they're going to give us a shape, a complex shape, and we have to break it down into individual pieces that we can determine the volume of and then add those together. So we're looking at an ice cream cone or a snow cone. Anyway, it has these dimensions. It's 26 inches across, so it's very big, and 17 inches tall. And we need to calculate how much volume there is in the top and how much volume is in the bottom, which it happens to be a cone. So for this exercise, you can go to Khan and learn about decomposing shapes, and you can do some exercises there. There's some practice units, and then you can also use the GED and WAMAP formula sheets. So here's the GED sheet. So we are looking at three-dimensional volume, right? And we are looking at cones and spheres. So not surface area, but volume. And so these are the formulas that we're going to need. For the cone, it's 1/3 pi r squared times h. So 1/3 of the equivalent cylinder using those same dimensions. And the volume of a sphere, a whole sphere, and I think in this case we've got just a half a sphere, a hemisphere. This is just half of one. So we're going to take half of whatever the value we derive from this formula. And that formula here is 4/3 pi r cubed. And then down here on the WAMAP side, we have pictures with each of those. 1/3 pi r squared times h, or 4/3 pi r cubed for the volume of a sphere. So we're going to have to remember we only want half of this value. So we'll take the whole cone, but only half of the sphere. Okay, let's see what that looks like. Let's see on the tablet. I've got this written out. And we're rounding the answer to 4 decimal places. So that was also in there, but I always forget to mention it. So round answer to 4 decimal places. So that's a lot. That's to the 10,000ths. So they really want to be precise about how much ice cream is in there. So let's give it a try. Area of a sphere is 4/3 pi r cubed. So here we have this line across here. The distance across is 26 inches. So we know that's the diameter, or d. So the r down here in the area of the sphere is going to be 26, right? 26. And that's r cubed because we've got, oops, someone's not thinking. Couldn't be me. All right. We're going to take half of the diameter to get the radius. So half of this, we'll put a dot here in the center, and we've got 13. And then they measure up to the top, which will also be 13. And then they measure across to the other side. So these are all at 90 degrees to each other. Those are their 90 degree angle between all of them. It's kind of hard to imagine. You have to have your fingers like maybe both hands. It's not going to work. Anyway, you've got 2 this way and then 1 more. And they're like this. So this is what you're measuring inside the sphere. That's the radius, but it's cubed. And so we still do everything in terms of area or volume with reference to a square, something with right angles. So these are all using right angles to get this cubic volume, okay? And then we know that the volume of a cone is equal to 1/3 of the equivalent cylinder. So whatever the volume of a cylinder is, a cone is 1/3 of that, and that's here. And we are going to leave this by itself. It's going to be 1/3. We're not going to need to change this. For this, to do a hemisphere or half of a sphere, we're going to need to divide this whole thing by 2 or multiply it by 1/2, either way. it ends up being the same thing. And then we're going to have to add these two together, the area of the hemisphere and the area of the cone. Okay, so let's go ahead and we've got this 4/3 pi r cubed. So let's do that. And if you guys are doing, if you're working toward the GED, please use your GED calculator. And if you're not, you probably have a better calculator than the one I'm using. I'm just going to use the browser. So 4/3 times pi, looks like I've done some of these already today, times 13. So important things to remember, take half of the value they give you. It was 13. So sometimes it helps to draw out a little diagram just to prevent mistakes and increase your chances of getting something right. So 4/3 times pi times 13 cubed. Okay, and then we're going to divide that by 2, but let's see what this is. Okay, so we got 9,202.77. Let's divide this by 2. So I'm going to click divide the answer by 2. And that's equal to 4,601. And I think in their instructions, they wanted that accuracy or precision to 4 decimal places. Okay, so we're going to take 5. We're going to take 5 because we're rounding. So this is what we're looking at. 4,601 and 4,601 and 38,603 100,000ths. So I'm just going to write that number down. 4,601.38603. So that's how much is in the hemisphere. That's cubic inches of ice cream. That's a lot. We're going to round this number, but then we also have to add it to, the amount in the cone. So we're rounding this to the 4 decimal places. So remember, rounding has a very specific algorithm or protocol. We're rounding to the 4th position, which is 0 is there. And we're looking at the number next to it, which is a 3. So it's not 5 or higher, so the 0 does not change. And rounded, this number would be 4,601 and 3,860 10,000ths. So this, that 0 stays there. So this is the volume of the hemisphere. So volume of the top, 4,601.3860 cubic inches. Now we need to calculate the volume of the cone, which 17 inches is like 1.5 feet, very tall. That's a big ice cream cone, lots of ice cream. And it's 26 inches across. This is not to scale. 26 inches across is like over 2 feet. I guess you can't see my hands because they... Anyway, you can imagine. If you like ice cream, it would be a nice thing. If you don't, it might be scary. Anyway, so what we're going to do next is calculate the value of the volume of the cone. The value of the volume of the cone. So we're going to do 1/3 times pi r squared times h. And we know that the r here is 13. So let's write that in. Let's go use purple. So 13 here, and h is 17. And everything else is given or constant. There's pi. So let's get my handy dandy faux calculator. So this time we have 1/3 times pi times 13 times 17. And hit enter. Ooh, that's not right. Oh, I did 13 to the 17th power. All right, we need 13 to the second power times 17. Okay, this was looking very scary. 1/3, let's bring this down to where we have the formula. 1/3 times pi times 13 to the second power, 13 squared, times 17. Okay, we should get a much more manageable answer this time. Here we go. 3008.59856. And I'm just thinking that before we round this is, I hope everyone's listening this far in the video. Before you give your final answer, you shouldn't round anything until you get to your final answer. So this didn't change, so we're going to be okay this time, but in the future, we got, you want to only round once in your math. Rounding is already making a mathematical answer approximate, 59856. And so in our case, this 0 would not change, but we're going to add these and then round, okay? So this answer is okay for rounding that number, but we're actually combining the two, and then we're going to round that answer, and that makes our answer more precise than adding up two rounded terms. So 3 plus 6 is 9. 0 plus 5, I guess we are allowed to use a calculator. I'm going to just do it this way because my real calculator's gone. Stopped working. All right, so I got 7,609 and 98,459 hundred thousandths. So we're looking at the fourth decimal place. So we're going to underline that one. And the number on its immediate right is 5 or higher, which means that that number that's underlined will increment by 1. That'll turn to 6. And the 9 falls away, and we can just bring down the rest of those numbers. 7,609 and 9,846 10,000ths. So this would be our final answer rounded, right? Let's go back to WAMAP and see how we did. This is the nerve-wracking part, especially when you're the teacher. 7609.9846, but anyone can make a mistake. So this is a lot of ice cream. Here we go. Submit the answer. And it was right. Okay, so just be careful not to round your preliminary answers too soon. You want to wait until you get all the way to the end and then round. Otherwise, you will introduce approximations into your work too soon and probably get the answer wrong. All right, this was a long video. I hope you watched it on 1.5 or 2.0 timing. Anyway, I recommend that always anyway. You can always slow it down. Anyway, give this one a try. You can get a similar question. Boom, here it is. Try that with these numbers. If you get stuck, click on that message instructor button and hit send.